Welcome to the 3D modeling video series. In this tutorial, we'll review common error messages or issues with importing files, particularly geological model volumes or solid bodies, for creating 3D geometries in GeoStudio. Using the import functionality in GeoStudio to bring in step files or geological model volumes provides a quick method for setting up the 3D geometry. However, when doing so, you may encounter an error message preventing successful import. Let us review the potential issues and what they mean in more detail. Firstly, your geological model volumes or step files may not import because there are degenerate triangles present. Degenerate triangles occur when one or more sides of the triangle is extremely small. If the geological model volumes are being imported from Leapfrog, this can occur because there is no tolerance to the numbers generated in Leapfrog. Therefore, a number can have 64 bits of precision, and triangle edges can be very, very small. When these triangles are brought into GeoStudio, where there is a set tolerance, numbers get rounded to a fixed number of decimal places. As you can see here, the initial triangle has one side that is very short compared to the others. After rounding, two of the vertices of the triangle are now at the same coordinate, meaning that one or more sides of the triangle has collapsed to a zero length. This results in the triangle having zero area. When importing geological model volumes with degenerate triangles, GeoStudio attempts to resolve the issue by relaxing the tolerance to allow for smaller triangles, but this is only up to a certain point. GeoStudio will produce an error if it cannot correct the issue on its own. Degenerate triangles may also occur in imported OBJ files. In the top image on the right, the OBJ has a large triangle in the middle that is seemingly connected to 4 triangles along its edges. However, there's a degenerate triangle with all 3 of its edges aligned such that it has zero area. This is highlighted with the yellow lines in the bottom image. The big triangle is actually connected to the long yellow edge and not to the 2 smaller yellow edges. GeoStudio can't generate a tetrahedral mesh with geological model volumes that have degenerate triangles because the mesher uses the triangles on the surface mesh, as you see them, to form tetrahedral. You can't make a tetrahedral with a positive volume using a triangle face that has zero area, as it results in a collapsed zero-volume tetrahedral. Another error message that you may experience when importing geological model volumes is related to naked edges. In a triangle mesh that encloses a solid, every triangle facet edge is connected to 2 facets. If the edge is only connected to a single facet, then there must be a hole or boundary there. Thus, a naked edge is one that is only connected to a single facet and results in gaps in the surface mesh. The surface mesh should be watertight for using the associated geological model volumes to set up the 3D geometry in GeoStudio. On the other hand, if the edge is joined to 3 or more facets, then you have some type of non-manifold structure. For example, if you are generating a single mesh with 2 cubes that share a common wall, it is difficult for GeoStudio to understand what is inside and what is outside in this scenario, as one side of the common wall is inside one cube and outside of the other. There must be a clear distinction between what is inside and outside for each cube in order to mesh and assign materials. GeoStudio can fix some types of non-manifold structures, like pinch-outs, but struggles with others, like the 2 boxes in the picture. Here on the right, you can see 2 views of a mesh with the non-manifold edges highlighted in pink. You can see how the highlighted edges are joined to 3 or more facets. In GeoStudio, let me demonstrate these 3 issues. I will start by importing geological model volumes from a file and select my demonstrations file that has degenerate triangles. When I do so, I get an error message. If I open the Task Manager, select the task that shows an issue, and click on Show Log, I can see the associated degenerate triangle error message. Watertight closed volumes are required for geological model volumes, and so the degeneracy is considered a flaw. After pressing Cancel, I will then import the OBJ file as a background mesh. I can import the file as a background mesh because it does not require that I have watertight mesh. In the imported file, the degenerate triangle is diagonal across the top of the cube. Now let us consider a geometry with naked edges or a hole. Again, I will try to import it as a geological model volume. As before, I see the red X in the Task Manager that shows there are naked edges in my mesh. When I import the file as a background mesh, you can clearly see the hole at the top of the cube. Finally, let's take a look at a mesh with non-manifold structures. When importing the file as a geological model volume, I now see in the Task Manager that I have an error message indicating that the file has non-manifold structures. When imported as a background mesh, if I change the opacity of the background mesh, I can see that there are two boxes sharing the same wall. In this case, GeoStudio has no easy way of determining what is inside and outside of this structure, since the outside part of one box is inside the other. This is a very simple example of a non-manifold structure. In more realistic geometries, we can get non-manifold structures where there are layers that pinch out, which are sometimes hard to decipher. Although it can be challenging and in some cases impossible, whoever is constructing the 3D geometry in GeoStudio needs to have better control over how the upstream geometry is being constructed. Depending on what application is used to generate these files, there are different approaches for resolving import issues. Errors when importing geological model volumes from Leapfrog may be due to CSG errors or constructive solid geometry errors, which indicate that the volumes are not valid. You can determine if a volume in Leapfrog is valid by right-clicking it and selecting Properties. A volume is valid if it is closed, consistent such that there are no self-intersections, and manifold where it can tell the inside from the outside. To fix invalid volumes, you can try the following to resolve it. Turn Adaptive Resolution off. Try to use a consistent resolution through the model as much as possible. Change the resolution of surfaces by a small amount. Enable Merged Output Volumes by double-clicking the geological model in the General tab. Increase the maximum snap distance if it's enabled in the Model's General tab. And finally, ensure there are no duplicate data points used as values, extents, or intervals. After making any of the above changes, check the volume's properties after each potential resolution to see if the volume has become closed, consistent, and manifold. For geological model volumes that are imported as OBJ files, these are typically made in CAD systems, which commonly have triangle mesh editing and checking features. CAD is frequently used for generating or manipulating triangle meshes for 3D printing and rapid prototyping. These types of meshes need to be relatively clean, which means that they can't have holes, non-manifold structures, etc., which are the same mesh requirements as GeoStudio has. CAD provides diagnostic tools for checking and fixing meshes, for example, to fill holes, remove degeneracies, remove non-manifold structures, and remesh to have better shaped or less triangles. Given these CAD diagnostic tools, we suggest that you attempt to fix your mesh at the upstream source rather than in GeoStudio. GeoStudio's 3D geometries are natively parametric, meaning that they are made of NURB space solids, surfaces, and curves. This type of geometry can be created in GeoStudio 3D or imported from STEP or IGES files. Parametric geometry can be used in or created with all of GeoStudio's 3D tools, including cutting, merging, sweeping, etc. However, you cannot do this with mesh-based geometry, for example, those imported using a geological model volume from Central or an OBJ file. When generating STEP or IGES files to import into GeoStudio, we often see poorly constructed CAD drawings that look nice on the screen, but upon closer inspection, surfaces are not connected to adjacent surfaces, or there are small overlaps, gaps, or intersections. These must be cleaned up at the source, as GeoStudio is not built for cleaning geometry. When creating CAD geometry for design drawings, CAD is often used like a sketch tool. However, to use CAD files for creating 3D geometry in GeoStudio, steps must be taken to ensure this geometry is watertight. We suggest following a rigorous workflow when constructing watertight geometry from scratch in CAD. For example, when creating a new volume that butts up against another volume, you should use the surface of the originally created volume in the new volume instead of creating a new surface. This ensures that the surfaces on the adjacent volumes match perfectly. It is not recommended to simply convert your mesh-based geometry to poly surfaces. This results in converting each triangle in your mesh to a triangle NURBS patch or surface. Overall, the poly surface will behave like a surface generated in GeoStudio, but it will be very slow. Finally, manually remove all unnecessary details. For example, objects that are close together, thin soil layers, or other aspects of the physical system that have negligible impact on the model domain or physical processes that you will analyze. In conclusion, GeoStudio requires watertight or valid solids that are closed, consistent, and manifold in order to successfully import STEP, IGES, or OBJ files, or geological model volumes directly from Leapfrog. In general, you can run into the same geometric problems with all of the discussed file types. GeoStudio's 3D geometry tools do not have the capability to automatically resolve issues or clean imported geometry items. Thus, regardless of the tool used to construct the geometry, you need to spend some time and care during the process. Try to simplify the original geometries as much as possible before importing them into GeoStudio. This concludes our tutorial video on common issues with importing files for 3D geometry creation in GeoStudio. For further learning, please visit the Sequent Learning Center for online courses and documentation. Thank you for watching.